Hi and welcome to video 6 for Unit 4 Topic 3 General Mathematics, and in this video we're going to talk about the Hungarian algorithm as we did in video 5, but we're going to run through some examples, or two examples to be specific, of this case. So here's our first one. It's contextual but mathematically fairly easy to run through. Here's a list of gardeners and the price that they have quoted for you to get a list of jobs done. They all need to be done on Saturday. So you plan to hire a gardener for one job each. What assignment gives the minimum cost? So there's my 4 gardening companies, and as you can see we've gone through that whole A, B, C, D process again, and we've got our 4 jobs, and it doesn't really matter what the gardening companies are called or what the jobs are. What we are going to do is apply the Hungarian algorithm in order to produce a bipartite graph so we can set up an assignment that will allow for the cheapest possible outcome. So the first thing we do in the Hungarian algorithm is we look at each separate row and we subtract the lowest value from each of those. And so I'm going to start with my matrices over here. They'll be 4 by 4, but I might not close it off yet until I see how big it is. 10s first. I'll be taking off 10 from each of them. 30, 50, 0, 100. Down here I've got 50 is the best, so I'll be taking off 50 from each of them. 0, 0, 0, 20. And 30 is the best here, so I'll be taking off 30, leaving me 40, 40, 0, and 20. And 20 is the best here, so I'll be taking off 20, leaving me 70, 50, 0, and 20. So there's my first matrix here after my row reduction, step 1 of the Hungarian algorithm. Now I'm going to have a look at whether I can cover my zeros in less than 4, because we've got 4 items this time, 4 assignments we'll need to make, in less than 4 lines. But I can see in this case that I can do it in 2 lines. And so therefore I need to carry on. And what I'm going to do now is a column reduction. So I'll be looking at each column, except for the third one because that's irrelevant, and reducing it. Now it turns out that in column 1 and 2 I've also got a 0 here already. There's my 0 and there's my 0. So when I reduce each of the values by the lowest value in that column, well, it's going to be just subtracting 0. So it actually turns out in this case, and in all cases, that my first, second and third column all stay the same. 50, 0, 40, 50, 0, 0, 0, and 0. But here I'm going to reduce the 20 off. So that gives me 100, 0, 0, 0, and I've got the 100 wrong there, sorry. I'm taking 20 off, so that gives me 20 there. Okay, now I'm going to look to see what I can cover up. And I can see here that I can cover up that row and then these 2 columns. So I can do it in 3, but I need to get it to 4. So I'm going to do a reduction again. This time I can see here that my lowest value available, this is the next step on the Hungarian Hungarian algorithm, sorry, is 30. That's the lowest one available that's not covered up. The 20 is covered up, so it doesn't count. I can also see that I've got 2 values, 0 and 0 here, that are covered up twice, and so they're going to be an important feature in this next step as well. So the first thing I do is I take 30 off each of the exposed values. So that gives me 0, 20. Down here it gives me 10, 10, and 40, and 20. And then I leave each of the ones covered up only once as zeros, or whatever they were, so that's still 20, 0, 0. But then I add 30 to the ones that are covered up twice. So that's 30 and that's 30. Now I look again. Can I cover them in less than 4? And that's a big one, that one there. I've still got this guy left. Can I do it better if I go that way? I don't need this. But it would seem like I'm stuck. I have to do it in 4. So I have no choice now, which means we're now at the stage where I can set up my bipartite graph. So I come back over here. I've got companies A, B, C, and D, and I want to do job 1, 2, 3, and 4. So I'm just going to do them in order. There's nothing special here. And so if that's 1, 2, 3, and 4, and this is A, B, C, and D, I now use the zeros as connections. So A, which I'll do in light blue, connects to 1 and 3 in my bipartite graph. And B, which I'll do in purple, connects to 1 and 2. And C, which I'll do in green, connects to 3 and 4. And D, which I'll do in orange, connects to 3 and 4. So I can see a few things immediately. C and D have to cover 3 and 4. Haven't worked out which way yet, but they have to cover 3 and 4. B, so A won't cover 3, which means A has to cover 1. B has to cover 2. It's the only option for 2. So my pairing is that B covers job 2, A covers job 1, C covers job 3, and D covers job 4. Or C could cover job 4 and D cover job 3. There's two possible answers here. The question does ask me to get the minimum cost, and so that's the main feature here. My minimum cost will be B is doing job 2, so that will be 50, and that's good because B is the cheapest for job 2. A is doing job A, and that's 40, and that's good because A is the cheapest for job A. Now I'll just call this minimum cost. C is going to do job 3, and D is going to do job 4. But if I swap that around and did it the other way here, I'd still get a total of $70 for those two jobs. But I'll do 30 plus 40, and it's going to cost me $160 to get those 4 jobs done by 4 different companies on the same day. And I know, you probably wouldn't get 4 different companies to come and do 4 different jobs, but that's the context of the question. So there we had the first example.